Welcome to Get Your FRQ On. This question is from 2014. It's question 2, and it is calculator active. In the question stem, we have a region in quadrant 1 bounded above by the horizontal line y equals 4 and bounded below by a function f of x. In part A of the question, we are asked to find the volume when this region R is rotated around the line y equals negative 2. Now, in the question stem, no bounds are provided. We don't know where these two graphs intersect, f of x and the line y equals 4, so we're going to have to use our calculator to find that information out so we have the correct bounds of integration. It is a calculator active question, so this should be fairly simple. I just need to figure out when x to the 4th minus 2.3x cubed plus 4 is equal to 4, and that turns out to be at x equals 0 and x equals 2.3. So our lower bound of integration will be 0 and our upper bound will be 2.3. Now if we're rotating this around the line y equals negative 2, we do have to take that into account. That's our axis of revolution. And so we have a big radius, which will be negative 2 minus the function which is further away from the line y equals negative 2, which in this case happens to be the line y equals 4. So our big radius is negative 2 minus 4, which is negative 6. And our small radius is going to be negative 2 minus our f of x. Here I have just f of x. It's actually negative 2 minus f of x. And then I have to set up a volume of revolution integral to find the volume of this solid. So the integral would be pi times the integral from 0 to 2.3 of negative 6 squared minus f of x plus 2 squared. All I did was factor out the negative there, dx, which is pi times the integral from 0 to 2.3 of negative 6 squared minus x to the 4th minus 2.3x cubed plus 6 squared dx. And since this is a calculator active question, not going to try to do this without one. Have your calculator do it. Volume turns out to be about 98.868. In part B of the question, we are asked to find the volume if cross-sections taken perpendicular to the x-axis are isosceles right triangles with one of the legs in the region R. Now, since cross-sections are isosceles right triangles with one leg in R, the area of each of these triangles should be pretty easy to find. We can develop or define an area function a of x, which is just 1/2 of 4 minus x to the 4th minus 2.3x cubed plus 4 squared. This is just the difference between the two functions, which would be the length of the leg. Squaring it gives us the area of a square, but these are isosceles right triangles, which would have half of that area, so that's why we have the half. So the volume of the desired solid would be, and again, use your calculator to do this because you're not going to want to do this by hand, would be the integral from 0 to 2.3 of our area function of x dx, which is this. Plug that into your calculator, and you get about 3.574 for that volume. In part C of the question, we are told that the vertical line x equals k divides the region R into equal areas, and we are asked to write an integral involving k that we could use to find the value of k. All right, so we haven't actually found the area of region R. We haven't done that in any part of this question. And it turns out that in this question, we don't actually have to know the area of R. We just have to set up an integral involving k, where if we solved it for k, we would have divided the region into two equal areas. So I don't need to know the area of region R, but it would be nice to have an integral that would find it, which in this case would be the integral from 0 to 2.3 of 4 minus this function x to the 4th minus 2.3x cubed plus 4 dx. that integral would be the area of R. I'm not going to actually evaluate it. I don't need to evaluate it. And what I need is some other integral involving k, which has half of that value. Well, x equals k is a vertical line, so k is an x-coordinate for something. I can just use the x-coordinate of k as one of the bounds. So if I use this integral, the integral from 0 to k of 4 minus the group, or the function x to the fourth minus 2.3 x cubed plus 4 dx, whatever that is, I need it to equal half of this integral. Remember, this integral is the actual area of region R. So if this one equals half of that, the value of k that makes that true would be the line x equals k that cuts it exactly in half.